Okay, Assalamualaikum and a very good day to you. So now we already reached our lecture 8. So we are going to discuss you're going to learn about the tolerance and the surface texture. So let's go and discuss about the limits and the tolerance first, and then we're going through on the surface texture. So first, what is the limits and what is the tolerance? So you need to know what exactly it is. On the tolerancing, okay, tolerance is actually a total amount of specific dimension is permitted to vary, or is tolerancing. While for the tolerancing is an extension of dimensioning. It allows us to specify range of accuracy for the shape, size, and position of every features of products, so that the manufacturer's parts will be fixed together and function properly when it be assembled. So as you can see in these figures, right? So there's two blocks. So there's green blocks and there's a white blocks, okay, like cream blocks. So we need to make sure it is tolerance between these two blocks, so it can be fit between each other. Okay, so we need to have these limitations, because if it's very accurate, means maybe your decimal points of accuracy more around decimal points around 5, so it's going to cost you more money. So we need to have like a limit, okay, for certain amount of tolerance between each part to be assembled together, or to be fitted together between, for example, like this picture lah. Okay, so it need to be fit between each other and need to be very tolerance and accurate. So tolerance. So here is given you the dimensions. Okay, the dimensions is around 1.500 plus minus 0.004 inches. So as you can see, the maximum size actually and the minimum size is going to be a value of 1.504, and the lowest going to be 1.5496. Okay, so actually this is going to be your limit. Okay, so means the maximum limit is 1.504 and your minimum limit is going to be 1496. So what exactly is the tolerance value? Your tolerance value is actually between your max and your minimum. So it should be, your tolerance is around 0.008 inches. Okay, you understand? So you need to know what is your tolerance and what is the limits. Okay, here you can see the terminology of the tolerance. So if you have, okay, as if you refer back on the last slide, right? So the size you have is around 1.500. So if you have like it mentioned, right, you are having 1.50 plus minus 0.04. So this is actually basic size plus a tolerance added. Okay, but it's actually, when you are using this, it only shows you the half value of your tolerance, because if you want to know the tolerance, it need to be your between the tolerance value is actually the value between of your maximum and your minimum, while the limit size is your this is actually the way you put your dimension. You put your limit dimensions, where you need to put your larger size is on top and your smaller size is on the bottom. So the limit size is between these two value. So tolerancing. So there's two different tolerancing methods. It's either be a limit dimensioning and the plus minus tolerancing. There's also many methods of ways to indicate a tolerance on the drawings, which are the limit dimensioning, plus and minus tolerancing, metric tolerancing, inch tolerancing, general tolerancing. So we'll go through each of these methods. Okay. Okay, on the limit dimensioning, okay, for this method we have the maximum value, which is the high limit. Okay, as you can see in the figures below, so shows you for the A is there's having two limits, right? So you already know we are having like a limit where you have a maximum and minimum. You have the height and your low limits. So if having a two limits means you need to show off your these two limits. So make sure you need to put that your high limit is on top while your low limit is on the bottom. Okay, as if you express in the single limit, okay, if you're having a single limit, means it can either be positive or negative. I mean you're going to be having a maximum or minimum value. So showing here is actually okay, it shows that okay, they have a radius showing you 0.03, so this is actually a minimum. Okay, so it will show you either be minimum or your maximum values. So we can see other ways actually later and other examples how to put if you have a single line or only having a single limit. So this is limit dimensioning for if for the circular features. So you have like these are the way you shows in your drawing. Okay, because it's circular, you need to have put on diameter symbols. If flat features, make sure you put it as a extension line, and then also put your limit dimensioning like this. On top of it is your maximum, and then your low value of your limits is at the bottom. Okay, it's all the same standard, either be a circular or a flat. So for the plus and the minus tolerancing, okay, this method, the dimension of the specified size is given first, and then you're going to follow by a plus or minus expression, okay, of the tolerancing. So as you can see on the upper figures, on the above part, where they're going to use on the metric drawings, metric units, okay, in units. So shows you need to put your dimension first, and then you can put followed by your plus and minus. So for the plus is for your maximum value, and your negative, your minus going to be your minimum value. So this way for the A, okay, this A part is actually for the bilateral tolerance, where you have a maximum and minimum. As for the unilateral tolerance, it's going to be having like only one direction, or you're only going to have like either be a maximum, to have like positive, a plus, or either be you're going to have like only minus. Okay, so if bilaterals, so this is the ways how you can put or express this method, okay, plus or minus method. So you need to put the plus and minus, or you can also put like simplified by plus minus 0.2, okay, because it's going to have the same value of the tolerance for the maximum and the minimum. So this also going to follows for the inch units, if you apply the inch units. Okay, and as for the unilateral tolerance, okay, if you're going to have only one way, either be positive or only to be negative, or if only you're going to have a max or negative, so means you just put like, okay, if for this one, okay, you can see for this example, okay, I'm showing you, so just follow this point. So I'm showing you it's a plus 0.5. So there's only one direction here, but still you need to put your 0 down at the bottom, means there's no minus value to the specified size. It's only going to have a tolerance on the plus on the values. So you're going to have a increment of 0.5. Okay, so this one for the second example, so they're only going to have like a going to decrease in the values. Okay, either B you need to put, okay, if it's a 0 for the maximum, so put 0. If you're having a minus, you need to put minus 0.4. Okay, make sure you need to understand that for 0 you don't need to have that that expression. I mean, you don't need to put either B plus or minus. Only if they're having a plus, then plus value, then you need to put this plus symbol. If you're having a minus, I mean there's a decrement on the values of the tolerancing, then you can put negative. As for the inch, okay, for the inch, you still need to put you still need to put your positive and negative, even though it only going to have only one directions. Okay, means only going to have either be positive or negative. Okay, even it's 0, so you need to put positive for the maximum. So negative, still negative, negative 0.1. And also for the second example here, you can see that it didn't change in the negative value, but still you need to put this sign, okay, this signage of negative, this signage of minus. So next on this okay, this is another examples of the bilateral tolerance you can go through for the plus and minus methods. So you need to normally be equal between these two. Okay, next on the metric tolerancing. So later we will discuss on the inch tolerancing. So I hope you can detect, okay, the difference between these two methods. Okay. Okay, let's go through on the metric tolerancing first. In the metric system, the dimension need not to be shown that they are having a same number of decimal places. So it need to be different. Okay, as shown in this example, okay, for first examples is 1.5 plus minus 0.04. Okay, your size dimensions is actually having only one decimal place, but for your tolerance limit is having 2 decimal place. Okay, so these two data, your size and your tolerance, cannot be having a same number of decimal places. It's same goes to the second examples, like 10 plus minus 0.1. So the 10 only have don't have any, and while 0.1 for your tolerance having a 1 decimal place. It's also going to apply on the bilateral. Okay, your size and your tolerance. Okay, your size and your tolerance should not have a same decimal places. But if you are having a different value of your plus and minus, your values for your upper and your bottom values should be having a same number of decimal places. Okay, please see the difference here. So your plus and minus need to have a same. decimal places, but your size and your tolerance limit cannot have a same decimal place. Here is another example. For this is only it's going to apply on the unilateral. So as I said before, for the matrix, so you only need to mention one way, right? It either be negative, it's going to be reduced, so you need to put negative. If it's going to increase, then you need to put positive. But if the other direction that not going to change, or you just state as 0, you don't need to put as positive there or negative here. Okay, just put only one sign, and it just state it either be positive or it's going to be negative. It's not negative, actually, it's minus. It's going to have a minimum or your maximum size. Okay, so we are entering on the inch tolerancing. Okay, in the inch system, the dimension is given to the same number of decimal places. Okay, it needs to be having same decimal places between the size and also your tolerance limit. Okay, tolerance. So here is 0.500. So they have like 2 decimal. As your tolerance limit is 0.004. So here also having sorry, it should be 3. This also going to be 3. Okay, you cannot having different number of decimal place. So as for the unilateral, okay, when you are only having like one direction, either be maximum or negative, first of all, remember you need to have same decimal places between the size and your limit tolerance, and your maximum values and your minimum values, either or it can be said also your positive, your plus limit of tolerance and your minus limit of tolerance need to have also the same number of decimal places. But the difference between these unilateral, between the inch and your matrix, that the other way, even if state as 0, you need to put the sign. Okay, so for this one, it's only going to have a plus. Okay, plus 0.500. But for it's not going to have a decrement, right, on this size. Still, even though you put a 0, you need to put a sign. The symbols is a minus. Here also shows you the degree, plus minus. So having also the same number of decimal places. On the general tolerance notes, okay, the use of general tolerance notes greatly simplify the drawing and save considerably layout in its preparation. Okay, for here is like it's just to generalize, actually, because if you are having too many dimensions and you need to put all the limits tolerance, it's too crowded. It's going to be, so if you have a specified you are only applied one decimal places, or you're going to have one limit tolerances, so you can put general tolerance notes. So here's some example where you just put except where stated otherwise, the tolerances on finished decimal dimension is plus minus 0.1. So it's actually conclude to summarize for all your dimensions size. This is the other examples. Okay, in inch, where for it state the range of the dimension, if it's up to 4.0, the tolerance is 0.04. So this actually summarized with different range, there are different tolerance. So by simplified, or by using these tolerance notes, is actually it will be making a less crowded, and it's much easier to understand. It clear, have a clarity, have clear, is easy to understand when you have this statement. So what about if you're having like accumulations of tolerance, where you have too many tolerance occurs? Okay, so there's many ways or many methods to show to do this dimensioning. It can be either be change dimensioning for or they also can be a datum dimensioning, and also the third one is the direct dimensioning. Okay, let's go one by one if you have too many tolerance. Okay, so first of all is the change dimensioning. So the change dimensioning is where the each point is measured to the next. Okay, so if okay, let's go on the second point is maximum variation between any two features is equal to the sum of the tolerance on the intermediate distance. So here if you want to have like a distance, right, you need to calculate this distance between point A to point B. So you just, okay, first of all you calculate up, I mean you add up the sum up of your size dimension. Okay, 0.750 plus 1.000 plus 1.750. Okay, first add up all, but it's also going to apply on your tolerance limit. Okay, so if you add up also on your tolerance limit 0.05, okay, it's going to be the same, so like 0.05 times 3, so you will get around 0.015. So it will give you the total length of AB is 3.515. So this is one way how to do the dimensioning with by having too many tolerance limit. So this is changed. So you just need to total out from this point, okay. Next is on the datum dimensioning. Okay, datum dimensioning is where a single reference point is used for all dimension in a single direction. So one single point, one single reference point, or if called is as a datum point. So here lah, this is your basic line. Okay, this is your reference point, this is your datum. Okay, it's the same question where you need to calculate the distance between the A to B. Okay, for this method, a maximum variation between any two features, okay, any two block or any two parts is equal to the sum of the tolerance on the two dimensions from the datum to the features. To the datum and to the features. So you add up first, okay. So you need you know the difference, right? The longest will be around 5. So A is around 1.5. So your size dimension is just need to minus up. So we'll get around 3.5. As for your tolerance, okay, tolerance is just a distance between A to B. Okay, here A is around 0.05, while the B is around 0.05. So if you sum up or you accumulate between these two, okay, these two, for this A is around 0.5, right? This one also 0.5. You add up, you're going to get a 0.10. So the maximum length of the AB, if you are referring to this datum dimensioning, you will get around 3.510. Okay, so make sure you understand the difference between these two. Okay, datum, you need to have a reference point. Okay, so this until A, and then this one is going to until B. So you just need to add up between these two. So the last one, for the cumulative tolerance is a direct dimensioning. Direct dimensioning is the maximum variation, okay, between these two any features is controlled by the tolerance on the dimension between the features. Okay, So you just need to calculate between this A to B. Okay, so you get right around 3.5. Okay, so allows the least variation between A to B, giving a total tolerance accumulation of around only 0.005. It's just a simple note because the others is also the same, so it's going to be the same too. So it's just actually a direct one, so you just can calculate it between the A to B. And then we are entering on the fits. Okay, so we are learning on the fits. So the fits is actually the interaction between the holes and shaft. Okay, you need to have the holes and you need to have a shaft. So this is going to be your holes, this is going to be your shaft. So interaction between this, is it going to be fit or not fit or something else? But you need to know that there's three types of general fits. First of all, you'll be going to have a clearance fit where the shaft always going to be smaller than the hole, so means nothing going to have there's not going to have any disturbance, means your shaft always can get into your holes. So this is called as your clearance fit. And then there's an interference fit. Okay, whereas the shaft always larger in the diameter than the hole, so you always have this like disturbance, and you where the interference fits also known as a force fits. Okay, because sometimes we need to use force to make the shaft get into the holes. So go through of these notes. And then the last one is the transition fit. Okay, this transition fits is a transition fit that exists when the maximum clearance, okay, is positive and the minimum clearance is negative. Therefore, the shaft may clear the holes with an air gap or may have to be forced into the holes. So actually, simple explanation is actually the transition fit is can either be fit or not fit. Okay, sometimes it can be fit because there's the maximum and the minimum make way to be fit, but sometimes it can't be fit. Okay, sometimes because their maximum and minimum between these two, their tolerance is different. So is the transition fit is can either be it can sometimes be fit or not fit. So you can go through all this. Okay, so this is showing you the comparison between these three phases. Okay, as you can see, the clearance phase mean maximum and minimum clearance must both positive. And then the interference phase, both the maximum are minimum interference, and then the minimum is max interference. So clearly they are going to have negative. This transition is positive maximum clearance and then negative minimum clearance. Okay, try to understand of all these fits. Read truly. Okay, from this note. As for the surface texture, so we are entering on the surface texture. Okay, so each material having a because you are using for the object, right? You may need to have like if you're using a metal or you're using a different material, sometimes like a carpet, for example. If you're using a carpet, but you need to design, so they are actually having a different surface texture, right? So why so it's very important to know or to to note what is exactly the surface texture of the materials on the drawing. On the drawing parts also. Okay, there's a two principal reasons for the surface finish control. First is where we can reduce the frictions, or we can control the wear if you know our surface texture. So these are actually the surface texture characteristic. So you try to read on more. There's a micro inch. What is micro inch? Okay, micrometers will be in meters. What is the roughness? And then there's a shows of the waviness, and then there's a lay. Okay, there's lay means that predominant surface pattern ordinarily determined by the production method used. Okay, and then there's also flaws on your material texture. So here is an example when you okay example of this surface texture characteristic. So means sorry. As for the flaw, it's like there's a scratch, so it shows here clearly on your surface right here. So there's a waviness. Okay, so here's this a pattern of the lay, and then what is the difference of the width. So this shows you different characteristic of these surface textures, and also the surface symbols. Okay, so the surface characteristic of the roughness, waviness, and lay may be controlled by applying the desired values to the surface texture symbols. So A is where it used when the surface may be produced by any method except when a bar or a circle is specified. So here is like the symbols you're going to use, and this is used when any surface characteristics are specified. Okay, this is like there's limit there. We're going through, actually you can go through along what is the symbols that they are going to use. Okay, as this one is actually for the metric for the custom or metric, or actually this is the present symbols, and this is what the last research of the symbols have been used. And also values is also shown in the micro inches and inches. So this apply in micro inches and inches, and while this will apply for the customary and the matrix. So the basic surface texture is like a right sign. Okay, when you put like you are correct right sign, basic surface texture. So there's a different texture when you have roughness. What you should do, there's a different symbols that you need to put on your surface texture symbols. Okay, if there's a roughness, there's a maximum and minimum here. There's waviness, what is the symbols. Okay, there's a lay symbols also. So how you put your symbols are shown here. Okay, go through one by one, learn and try to be familiarized about this data, notes, and symbols of the surface texture. So here also the typical applications of the surface. Okay, and then the surface roughness. What is the process that going to have that surface roughness? Sometimes we have snagging or drilling or milling. So this is what the rate of your micrometers or micro inches. Okay, go through it of these notes. So here shows you the typical surface roughness with the height. Okay, if you have height and applications. Okay. So this table shows you the typical surface roughness height application. So this is for the microinches, and this column is for the micrometers. It's going to have a different values for sure. So go through what is the application, what is the difference between these applications. So having different numbers, going to have different applications. So this is continuation from the last slide. Tables, have a look, try to read, try to understand. Okay, I'm not going through one by one. I'm pretty sure you're going to not remember, but it's okay. Try, just have a look. Okay, and then this is an others examples. If you have like roughness height ratings and their equivalents as and series. Okay, this is another application, how it shows. And this one is for the lay symbols. Lay is not only going to have one, it can either be a parallel, perpendicular, angular. So different design of the lay. Okay, you may have different symbols. Okay, try to check all of these symbols. Okay, for the lay symbols. And then how they put it for the lay symbols. Okay, they put it C here. Okay, this how they present the symbol of lay, so you can check here. And then this the notes. Okay, the notes relating to the surface roughness can be local or general. Okay, so this is for the local surface roughness, local note, where you just you put a point here. Okay, shows here, this is local, right? X hone. So the roughness value shown in the micrometers. So this one is going to be your local notes. As for the general notes, mostly they're going to have like some explanation, all surface, what is the numbers of your surface roughness and all surface, unless otherwise is specified. Okay, they give you a bit simple explanation. So the x-axis is actually not x-axis. You need to have a certain number. So you need to go through all the tables that I shown you before on the last slides. Okay. So the machine surface. In preparing a working drawings or parts to be cast, molded or forged, okay, the drafter must indicate the surface on the drawing that will require machining or finishing. So the symbol identify actually those surface that produced by machining operation. So I will be removal by material machining is optional or obligatory. So this to indicate, okay, that the material is to be provided by for removal by the machining. So for the machine surface, when all the surface are to be machined, a general note such as a finish all over may be used. Okay. So remember, if you have a general note, it means there's some a simple explanation. Okay, simple explanation. So it just it's like make a statement here there. And then finish all over, maybe use the symbol on drawing, maybe omitted. Where space is restricted, the machining symbol may be placed on the on an extension line, and the machining symbols are not normally cannot be duplicate. So it shows here your machining line obligatory. Okay. So this is application of surface texture symbol when machining of surface is required. Okay, this part. So take note on that. There's a machine surface. Also here, one example on the metal drawing, metal objects of drawing. And here, When it is desirable to indicate the amount of material to be removed, the amount of materials in inches or millimeters is shown to the left of the symbols. So this shown that having a machining allowance in millimeters. So these numbers is actually, okay, this value is actually indicate you the amount of material to be removed, either be in inches or millimeters. Okay, it's going to be put on your left of the symbols. So this is going to be end of this lecture. I hope you all go through all the slides, try have a look, try to read. I may going to test you next time when I see you. Okay, thank you.